Hello everyone and welcome to the Multimedia Sherpa channel. I'm Paul Spencer and we're going to do something a bit new today. We're going to do an in-game tutorial where I talk about a subject whilst playing a computer game. The game we're playing today is Agario or agar.io, depends on which way you say it and how cool you are. And we're going to be talking about the differences between raster and vector graphics. The reason why I've chosen to play this is because essentially Agario uses vector graphics. Now I have to apologise for my gameplay here. I'm not the best at this game, but it uses vector graphics. And what vector graphics are is they are essentially simple shapes and colours made out of mathematical equations, as all shapes are. Now the reason why computers in general are big fans of using vector graphics is because they're generally pretty good at calculating them. You know, that's essentially what computers do. They work off numbers and they calculate things. And so what happens is, you know, a computer will see a thing, you know, a shape like a circle or like a square, and it will figure out kind of how big that particular shape is in a very short amount of time, and it will figure out the color that's being used as well in a very short amount of time as well. It generally figures out the colors by using things like hexadecimal code to kind of chart the color and any changes to it and things like that. And Agario is actually very good at doing that because your circle gets bigger and bigger. I say they're all vector graphics. So vector graphics as well take up very little space because, as I say, it's just a sum for the computer to look at. Raster graphics, on the other hand, they're a bit different. Now, a typical raster graphic format would be a JPEG, which is used for just about, you know, I think between JPEG and PNG, most of the images on the internet are covered. And raster graphics are used for kind of detailed pictures, or, you know, even photographs and things like that. Or actually generally used for photographs. And the way raster graphics work, they work very differently. Is they're measured in pixels. So each little dot has a value. That value is normally attributed to a color, again in hexadecimal form. And the computer kind of sums up the value of the image by checking the value of each individual pixel in the image. So if you've got an image with a huge resolution, you've got yes, sorry, playing a game and trying to explain. Right, I'm pretty much buggered here. So where was I? Raster graphics. Yes, this is one of the problems I think with playing games and trying to explain what's going on. Oh no. So yeah, raster graphics are essentially built up with lots of little images. Lots of little pixels, each having a value. So if you've got a high resolution image, then it's going to be a lot of data for the computer to kind of put together, which is generally why raster graphics aren't used as much, you know, in applications and things where stuff has to happen on the fly, you know, because there's a lot of calculations there. It would be very difficult it'd be much more difficult for a computer to make a raster graphic larger and still keep its kind of file size and quality, as opposed to a vector graphic, which is essentially just changing the numbers, or, you know, within an equation. For example, we can put that into terms that we would understand is if you've got you know, how to find out the size of a square is, you know, the width by the height, or a rectangle even is, you know, the width by the height, and to get a bigger square we just make the numbers bigger in the width and height. However, in raster graphic formats, what we've got to do is we've got to measure each point of that square or rectangle, I'm dead, and then kind of extrapolate that and keep each value and then times them by 4 or times them by 2, depending on the dimensions that we go in. So that's kind of a very, hopefully this has come out okay. It's a very quick overview of the differences between vector and raster graphics and what they might be used for. Okay, cool. Alright, so yeah, hopefully you've learned something from that. I've had fun playing a game and trying to explain what's going on. And we'll see about doing a couple more of these in-game tutorials. Alright, cheers.
Watch telly.